Hey, AP Back Row students, it's Mr. White here with some notes for you about money growth and finance. And we're going to start today with a little quote from Ben Franklin, the guy who's on all of our $100 bills. He once said, "Money makes money, and the money that money makes more money." What is Ben Franklin talking about? Well, I'll tell you what he's talking about. He's talking about something called compounding interest. Do you know what compounding interest is? Well, if you don't, then keep watching. We're going to talk about it in this unit. So go ahead and get out some notes and follow along as we talk about money growth and finance. All right, so we know money doesn't grow on trees, right? But money does in fact grow. And as a matter of fact, as you get older and you start making some real money, you're going to have to figure out a way to invest your funds. So when people invest money, it means they're putting money into something that they hope will bring them more money in the future. And so finance is just the field of economics that studies how people do that, right? It's the field of economics that studies how people make decisions about the management of their money and how they handle financial risks by allowing their money to grow and become diversified in all kinds of different investments. So if you've ever heard of this idea of finance before, or you heard about people trying to get their finances together, that's what they're talking about. Now, finance really rests on two main principles, and these two principles are a part of something called the time value of money. Time value of money just simply means that an amount of money today is going to be worth more or less in the future due to things like inflation and interest rates. So the question we always have to ask ourselves when we're investing or trying to manage our money is, how much would an amount of money today be worth at some point in the future, right? Or how much would an amount of money in the future be worth today? If we're talking about how much the amount of money today would be worth in the future, we're talking about the future value, the amount of money in the future that an amount of money today would yield given the prevailing interest rates. So like, for example, if you had $100 today, it's equal to about $103 in a year if we're talking about 3% interest. So the future value of $100 at 3% interest is $103. Now the present value means the discounted value or the current worth of some money today for a future payment. So in other words, if you're trying to negotiate a contract, somebody's offering to pay you a certain amount of money, a certain amount of time in the future, you could come up with a figure that represented how much you would need to have today to invest to have that exact same amount of money in the future, right? So for example, if somebody offered you $100 a year from today, that's equivalent to receiving $97 today if interest rates are currently 3%. That just means that if they paid you $97 today, you could invest it at 3% and you would have the exact same amount of money, $100, 1 year from today. Now, there are two different ways to calculate present and future value. One way is by using simple interest approach. The other is with what's called compounding interest. Now, there aren't very many investments out there in the real world that just use simple interest. Most use compounding interest, but let's real quick talk about simple interest. Simple interest is when an investment only gains interest on the principal. Okay, and the principal does not mean Miss Hardy. Principal means the amount of money initially invested. So the formula for simple interest is just the principal times the interest rate times the amount of time, right? So like, for example, $100 times 5% times 5 years. So essentially it's only the principal that's generating the interest. Compounding interest, on the other hand, is when you have an asset that generates earnings on its earnings, right? It's when you can get interest from your interest. Okay, and so like your earnings generate their own earnings. It's pretty amazing. Both the principal and the interest can earn interest. As a matter of fact, that smart guy right there, Albert Einstein, once said, "The most powerful force in the universe is compound interest." That's my German impression. Thank you, thank you. Yeah, in other words, he's saying like this is really amazing if you understand how to use it. It's a very powerful force. Like you can think of it as like an infinity gauntlet of finance. So here's the formula for finding the future value of a present sum of money. The future value is equal to the principal times 1 plus the interest rate compounded, or to the number of years compounded. Excuse me. So you can see there it's an exponent, right? N is the exponent. So let's take a look at an example of how we would use this future value formula to answer a question about finance. So let's determine the future value of $1,000 using simple interest and compounding interest. And we'll just go ahead and lay it out. We'll lay out our information. Here we go. So the principal, the amount we have to start with is $1,000, right? And let's say that there's a 20% interest rate. Wouldn't that be amazing? In your calculator, you can just put 0.2. Remember that whenever we're doing percentages, we got to put these in as decimals. Don't just put 20 in your calculator. You're going to get a wild answer, okay? And let's say that you're going to invest this $1,000 at 20% for 10 years. What we want to know is, how much benefit are you going to get? In other words, how much is your $1,000 going to multiply into over the course of 10 years if you're investing it at 20% interest? Let's start with simple interest, okay? So for simple interest, we're just going to do 1,000 times 20 times 10. I'll give you a second to go ahead and work that out. All right, 1,000 times 20 times 10 is equal to 2,000. So that means that's how much we're going to have in interest, and overall the total value of the asset will be the interest plus the principal, right? So the principal was 1,000. The interest that we're going to earn on that 1,000 is 2,000, right? And so overall we'll have $3,000 in assets. That means, like, if you put that into some sort of an account, like a bank account, if you left it alone for 10 years, when you look at the balance on your bank account, it will have gone up from 1,000 to 3,000. Man, not too bad, right? Of course, you got to keep in mind you can't touch it for 10 years, so a little trade-off there, some opportunity cost, right? But let's see what happens if we do compounding interest, okay? Remember that with compounding interest, it's the future value equals 1,000 times 1 plus the interest rate. So in this case, 1.20 to the power of 10. Okay. That means that our $1,000, when we look at our account balance 10 years from now, is going to be worth $6,191.74. Now, if you just subtract 1,000 from that, that tells you that we generated $5,191.74 in interest. Whoa, wow. So now let's think about this for a second. Now, there are very few investments you could ever get that pay you 20%. That would be amazing. But I can tell you there is something you can get where you pay 20% compounding interest, and that's a credit card. As a matter of fact, guys, if you were to run up $1,000 on your credit card and you didn't pay it off for 10 years, that is what you're going to see on your account balance, right? You're going to actually, you might actually end up owing a lot more than that, because a lot of the times credit cards are going to charge you extra fees and things on top of the amount that you've already spent. But like if you spent $1,000 on your credit card, and they're compounding that at 20% interest yearly, which actually credit cards compound monthly, so it would end up being slightly higher than that. Yeah, you're going to end up owing a little over $5,000 in interest on that credit card. So if you've ever wondered how do people get into so much credit card debt, it's all because of compounding interest. Now, let's think of something a little bit more positive. Winning the lottery, as we talked about before, right? I guess that could be your investment strategy. So if winning the lottery is your investment strategy, of course you're dreaming of the day when you're actually going to do that, right? So let's imagine a dream scenario where you got one of those, Texas two-step lotto scratch-off tickets. Maybe you just bought it down at the corner store. You scratch off, you get the first one. You scratch off, you get the second one. You get the third one, whatever. I don't know, like Bell Cherry. I don't know what you got to get. But whatever you got, you won $1 million. That is amazing, right? Now, I don't know if you guys know this or not, but when you win the lotto, you don't get all the money up front at once. Generally, they pay it out to you over time. So let's say, for example, your jackpot of $1 million, the Texas Lotto says they're going to pay it to you over 10 years. So you're told you can either collect a lump sum today, right, of $510,000. That means, hey, they'll just write you a check for 510 grand today, but that's all you're going to get. Or you could take $1 million spread out over 10 years. So that's $100,000 a year. Wow, what a tough question. Now, guys, this is actually what they do when you win the lottery. They'll offer you a lump sum up front, and if you take the lump sum, you don't get the full amount, but you get money up front, or you could take a smaller amount paid out over several years. Well, to know what to do, we have to find out what is the prevailing interest rate we could earn on an investment. In other words, if we took the money and invested it today, would it be worth more to us over 10 years to get the payments and receive the full $1 million, or to take $510,000 today and invest it at 7% interest, Would we have more than $1 million after 10 years, or would we have less than $1 million after 10 years? Well, that is the real question we're trying to answer here. And that'll tell us whether we should take the lump sum or the annual payments of $100,000. Now, to do this, we have to do what economists call discounting. Okay, discounting doesn't mean you're getting money knocked off the price of something you want to buy. Discounting is a process of finding the present value of a future sum of money. The formula is a lot like the one we just saw for future value, but it's just turned upside down, right? So instead of multiplying, this time we're going to divide. The present value is equal to X, which is the amount that's being promised to you over some period of time, right? So in this case, it would be $1 million divided by 1 plus R. This sounds familiar, right? R is the interest rate to the power of N. N is the number of times compounded, so the number of years, okay? So basically, guys, let's just practice, okay? Let's say if you had $200 that's being offered to you 10 years from now. Maybe there's a 5% investment. If there's a 5% investment, how much would $200 10 years from now be worth to us today? Well, if we had 5% investments available, we'd do 200 divided by 1.05, because that's 1 plus 5% to the power of 10, which equals 123. That means that if you had $123 today, you invested it at 5% over the space of 10 years, you would end up with $200. Okay? Why don't you try the next one, 8%? How much would $200 be worth today? What would be the present value if there was an 8% interest rate out there? You think it would be worth more than $123 or less? Okay, find out. Yeah, $200, right, divided by 1.08 to the power of 10 is 93. Yeah, it's less. You need less money. So that's something interesting to notice there. The higher the interest rate is, the smaller the present value is going to be for a future sum of money. In other words, if we had a high interest rate like 8%, we would only need $93 today to invest to end up with $200 after 10 years. But if the interest rate is smaller, if it's 5%, we need a bigger sum of money. We need $123 to invest over the course of 10 years to end up with $200. So let's go back to that lotto example. So you just won $1 million in the lottery. You're told you can collect a lump sum of $510,000 today, or you can take payments of $100,000 spread out over 10 years. What do you do, right? Remember, we said we're going to assume that we can get a 7% real interest rate on our investment returns. So here's what we're going to do, okay? We're going to take that present value formula, X divided by 1 plus R to the power of N. So in this case, X is $1 million. Right? 1 plus R means 1 plus 0.07. R is the interest rate. 0.07 is a 7% interest rate. And the power of N, in this case, N is 10 years. So go ahead and work that out and tell me, should we accept $510,000 today, or should we go ahead and take the payments over the course of 10 years? Would it be better for us to just take the $1 million spread out over 10 years? Remember that if the lump sum payment is more than the present value, then we should take the lump sum. If the lump sum is less than the present value, however, then we should go ahead and take the payments. So go ahead and work it out, work it out. Yes. Present value is $508,349.29. So that's less than what they're offering us right now. That means we should go ahead and take the 510 grand, right? Take the money and run instead of the $1 million spread out over 10 years, because you would have a real gain of $1,611.59. That means you're going to actually get more money if you accept the $510,000 instead of waiting to receive $1 million spread out over 10 years. Although, keep in mind, that means that you're not going to be able to spend the $510,000 today. You're going to have to take that money and put it in that 7% investment and not touch it for 10 years. Then you would actually end up with more than $1 million. But once again, you'd have to be patient. So I hate to break it to you, but one way or another, you're going to have to wait till you're like 27 or 28 before you can go buy that Lambo that you were dreaming of with your $1 million. Okay, the last thing we're going to talk about today before we wrap things up is has to do with nominal interest rates and real interest rates and something called the Fisher effect or the Fisher equation. It's named after this economist named Irving Fisher, who helped us basically figure out, as long as we know the nominal interest rate and the rate of inflation, we can figure out the real interest rate. As long as we know the real interest rate and the nominal interest rate, we can figure out the rate of inflation. There's a couple different formulas I'm going to give you to be able to figure out, and it's actually really simple. Okay, so the real interest rate is equal to the nominal interest rate minus the rate of inflation. That's one of the first ones I want you to know. So go ahead and write that down. So let's say, for example, if a bank posts a nominal interest rate of 7% a year, and let's say that inflation is 3% a year, we can figure out that the real interest rate is 4% a year. Well, how do we know that? Well, we use this formula right here, right? So we would say 0.04, that's the real interest rate, is equal to 0.07 minus 0.03. So if you knew that the nominal interest rate is 7% and inflation is 3%, it's very easy to figure out what's the real interest rate. Another way you could do this is think of it the opposite way, right? Nominal interest rate is equal to the real interest rate plus the rate of inflation. So we could say 0.07 is equal to 0.04 plus 0.03, right? If you knew that the real interest rate was 4% and inflation was 3%, and I'm asking you what's the nominal interest rate, just add those two together. Easy as can be. There's one more complicated way to do it if you'd like, if you're an algebra kind of person. 1 plus the nominal interest rate is equal to 1 plus the real interest rate times 1 plus the rate of inflation. So in other words, 1.07 is equal to 1.03 times 1.04. And so all these are just some different tools you can have in your toolbox to figure out how to calculate the real rate of inflation, or the nominal, or excuse me, the real rate of interest, the nominal rate of interest, or the rate of inflation. And so all this is, like I said, just what we call the Fisher effect, because it was developed by that guy, Irving Fisher. It's just, it tells us that the nominal interest rate adjusts to inflation. Okay. Now, the last thing we're going to get into here is a little bit of like history and theory. It's not super important for you to know all this stuff, but I'll kind of point out the stuff that you do need to know. When we talk about monetary neutrality and the classical dichotomy, what we're talking about is, a dichotomy just means a division into two groups, right? There are some people who believe in a division between the real side of the economy and the monetary side of the economy. It's just sort of a theoretical separation of nominal and real variables in the economy. Nominal variables, of course, mean variables that are measured in monetary units, not adjusted for inflation, think like nominal GDP, and real variables mean variables that are measured in physical units, accounting for inflation. So like real GDP, real interest rates, income after inflation and taxes and things like that. So monetary neutrality just means that, there are people who believe that changes in the money supply don't have any effect on real variables. So in other words, like there are people who believe that even if you increase the money supply, it's not going to change real GDP. It's only going to affect nominal variables, like for example, nominal GDP, which is not very useful in most cases to us when we're studying the economy. Now, what we found later is that it all depends on the time horizon. So monetary neutrality is only applicable in the long run, but not the short run. What I mean by that is that in the long run, yeah, the amount of money out there doesn't really change how much stuff the economy can produce. But in the short run, more money out there can pump up the economy for a short period of time. Now, one of the first economists to ever really explain this was Milton Friedman back in the 1960s and 70s. He was an American economist who ended up winning a Nobel Prize for economics. He's considered the father of this thing called monetarism. It's the theory that real GDP will grow steadily if the money supply grows steadily. So like, for example, if the money supply grows by 2%, maybe 3% a year, GDP is also going to grow by about the same amount. And so this is sort of I guess you could say, the philosophical foundation of monetary policy. So make sure you know monetarism, just associated with Milton Friedman, and it's just the idea that if we want to stabilize the economy, we got to stabilize the money supply. Now, one of the most important tools that economists need, especially in the Federal Reserve to conduct monetary policy, is they need to understand the velocity of money and how that affects the quantity equation. When we talk about the velocity of money, I don't mean that money can drive around. I mean, how quickly is money being exchanged in the economy? We talked about the multiplier, how when you buy something, money doesn't just stay in the person's pockets or in the cash register. It keeps getting exchanged over and over again. So the velocity of money is just the average number of times that a dollar is used to purchase a final good or service during a year. It's basically the speed at which a dollar bill travels from one person's wallet to somebody else's. And basically, that tells us how many times a dollar can be used to purchase a newly produced good or service in 1 year. Okay, and this is important because if we're going to conduct monetary policy, we want to have an idea of how quickly money is being spread through the economy. If we put too much money out there but nobody's buying anything, that's going to lead to massive inflation, and that would be bad. So here's our equation for the velocity. The velocity is equal to P times Y divided by M. In this case, P is the price level, think the CPI. Y is the level of real GDP. And M is the quantity of money, so how much money is out there in circulation. And that'll tell us really easily, basically how fast is the economy going right now. Okay. Now, once you know the velocity, we can plug that into this thing called the quantity equation. The quantity equation shows that the money supply has a direct proportional relationship with the price level. In other words, this proves that idea of quantity theory inflation that we talked about in the last unit. The idea that if we put too much money in circulation, it's going to lead to runaway inflation. Think like what happened with Zimbabwe and those, billion and trillion dollar bills. So quantity equation is basically what you see here in this little blue box. M times V equals P times Y. In this case, M, once again, is the quantity of money. V is the velocity, so the money supply times the velocity is equal to P is the price level, so we're talking about the CPI, and Y, once again, means output, so real GDP. So the quantity of money times the velocity should equal to the CPI times real GDP. Okay, pretty simple. So as long as you know 3 of those, you can always find the 4th one just by using a little bit of algebra. Okay, so classical economists believed that the velocity of money was constant, that it never changed, and that real GDP was unchanged by any increases in the quantity of money. Basically, Y and V were unchanged by increases in the money supply. That was what most people used to think, but now ever since the 60s and 70s, we realized that increases in the money supply actually lead to proportional increases in the price level. However, it doesn't always work that way. I mean, sometimes we can actually increase the money supply and the price level doesn't increase that much. And there's a lot of uncertainty around this. And as much as our theory works out, most of the time, there's still a lot of unanswered questions. And a lot of this actually just comes down to consumer expectations and other forces that are happening in the economy. So that's basically it today, guys, for our monetary policy notes about the velocity of money and finance. So if you have any questions about this, and I know this is a lot to take in, so you probably got a question or two, just make sure you email me. You can contact me on Remind or Google Classroom, or of course you can just do that good old-fashioned thing and ask me in class. Remember to subscribe to my channel, and I hope you all have a great day.